Good evening and welcome to our February Heritage Lecture. Thank you for joining us. My name is Allison Summers-Sayre. I'm the Executive Director of the Delaware River Greenway Partnership. DRGP works to preserve and enhance the natural, cultural, and recreational resources of the lower Delaware River in New Jersey and Pennsylvania. The Heritage Lecture Series is generously funded by the Pennsylvania Department of Conservation and Natural Resources, and we thank them for their support. Tonight, we have a very timely lecture titled Attention Drains to Rivers, the Assault on Our Fresh Waters. Our speaker, Erin Stretz, is going to tell us more about the impact of the millions of tons of salt that is applied to roads during the winter. Erin will draw on the data produced by the NJ Salt Watch, launched in 2020 by the Watershed Institute in Pennington, New Jersey. Erin is the Assistant Director of Science at the Watershed Institute. She leads the New Jersey Watershed Watch Network, a cooperative program of the Institute and the NJ Department of Environmental Protection. She has a master's in environmental science from Oregon State University and started her work in NJ water quality in 2007 as an AmeriCorps watershed ambassador for the Crosswicks Creek. My colleague Cindy will facilitate questions after Erin's presentation. Please add your questions to the Q&A section rather than chat. Feel free to do that at any time during the lecture, and they will be answered at the Q&A session in the end. So now I'll turn it over to Erin. Thank you.
Hey, thank you so much, and thank you for having me, and thanks to everyone here for joining us this evening. This is a very timely lecture. We're going to be talking about road salt today, the problems, the issues for water quality, for the bottom of your car, and then we'll start talking about some actual solutions. So first, I'm Erin Stretz, Assistant Director of Science and Stewardship at the Watershed Institute. Our organization, we're a nonprofit watershed association that was founded in 1949, and we have grown quite a bit since then to have a team of about 40 people who work across different sectors like education, advocacy, land stewardship, and science, where I work, all working towards a singular goal, and that's to protect and restore the waters and natural environment of central New Jersey. So central New Jersey is a real thing. And here's one look at it, the kind of western portion of central New Jersey. This is where we're most active at the Watershed Institute. We cover the Millstone watershed and then the adjacent portion of the Delaware watershed from Lambertville to south of Trenton. The main program that I run is called the New Jersey Watershed Watch Network. This is hosted by me at the Watershed Institute, fully funded by state government or the New Jersey Department of Environmental Protection. And our whole goal is to maximize the amount of water quality data we're collecting to be able to produce a comprehensive assessment of water quality across the state of New Jersey. And so the way that we can do that is we can tap people who are already out in the community collecting water quality monitoring data. They might be referred to as New Jersey Community Water Monitoring or volunteer monitors or citizen scientists or participatory science. These are all kind of synonyms for the same type of thing. It's just folks that are not working for the government, not working for DEP, but are out there collecting data. So there's currently about 40 groups across the state that I primarily work with, and that ranges from other watershed associations similar to the Watershed Institute to kind of nature centers and universities and environmental commissions. And so anyone who wants to collect data for regulatory purposes, you can feel free to contact me, and I can provide training and some technical assistance in preparing quality assurance project plans and regulatory guidance to make sure that you are collecting data at that known and sufficient quality. So we want to know where the data is coming from. We want to make sure that it's being produced correctly so that the decisions we make based off of it are sound. So that's a little bit about me. We'll just jump right into road salt, the problem with road salt. But first, we'll talk about why we use it and what it is. So road salt today, Definitely saw some road salt out on the roads. And why is that? That's because when it snows outside, we still want to get around, right? So if you've got an emergency situation, this was a photo from a news article in Central PA in 2017 where there was an emergency situation. Neighbors had to come out and shovel out this ambulance so that that person could get medical attention. Of course, the other ones are a little bit silly, and the person on the right kind of looks like a vampire saving that car a little bit. And that UPS guy, you know, whether it's pizza or your other deliveries, it's important that we kind of keep things moving, right? And keep people safe. So road salt is one way that we can do that. The way that salt works is we apply it to the roads. It reduces the freezing temperature of the snow and the ice to kind of initiate melting after the snow has already fallen, or to prevent accumulation of the snow on roads and sidewalks in the first place. So the primary people who are applying salt to our roads and sidewalks, it kind of depends where you are, but these are the three big applicators. Municipal departments of public works, they are responsible for all municipal roads. They tend to have those big kind of salt huts where they store everything, and it's built into the municipal budget for them to maintain public safety. State roads are managed by the New Jersey Department of Transportation, and everything else, residential properties, commercial properties, that's all managed by those distinct property managers. So there are regulations out there that sort of regulate how municipalities and how states manage roadways, but much less so for how residential and kind of private commercial property managers manage their own. But we'll talk about some kind of best management practices for that before we end today. So this is a common sight. This is kind of a larger truck. It's applying rock salt onto the road, and you can kind of see it. It's kind of scattering it directly onto the road. And then another way that we tend to see salt applied is in liquid form. So this is a liquid brine anti-icer. So you'll notice that I'm using two different words here, de-icing and anti-icing. So typically anti-icing means that you apply that brine before there's any snow, kind of forms a seal almost with the road. And so before the snow falls, you're just preventing that accumulation from happening in the first place. De-icing happens after the snow has fallen. You kind of have to do that mechanical removal of the snow by shoveling or plowing, and then you can apply that rock salt. And so over the years, we have definitely adjusted we as in like American people, have adjusted our expectations on getting around during a snowstorm. There was once upon a time when it snowed outside and you stayed inside, and you did not expect the pizza guy to come over, and you didn't expect to leave the house. But as the highway system sort of expanded during World War II and after World War II, then there was this kind of expectation of what they call the bare pavement concept. So, shoveling, plowing those roads, and then applying the salt afterward, making sure that everything is kind of just clear and clean and ready for travel. Our use of road salt has definitely grown over the years. This has to do with those expectations, but also just with how many roads we're building, and kind of needing to make sure that people back in the neighborhoods have their free pathways of travel and everything. But we tend to overdo it when we apply road salt. A lot of times people will apply the salt wanting to feel that crunch under their feet. And there is something to be said for using an abrasive like sand or kitty litter to provide that traction. But that's a totally different product. We're talking specifically about road salt here. So it should not feel crunchy under your feet. This is a picture, I think I'm kind of calling someone out here, unfortunately, but this was a picture from early last year of kind of the aftermath and kind of situation as it was happening of a shopping center in Princeton applying salt to their sidewalks. As we'll learn a little bit later during this talk, we only need about 1 grain of salt every 3 inches or so. So kind of imagine them spaced out that widely. Obviously, this is too much salt here. And so we use a lot of salt. Why do we care? Well, we are seeing the effects of that salt, and we're seeing it in our freshwaters. Here in New Jersey, our median chloride levels have tripled since 1997. And so in this image, I'm going to show this line here. This shows the 50 milligrams per liter chloride level. This is kind of a threshold level for healthy or sustainable freshwater ecosystems. Generally, if we remain below 50 milligrams per liter, we're kind of, it's not really affecting, the ecosystem in a major way. But when we exceed that threshold, then we start to see sort of cascading issues as a result. And so you'll see that in the most recent part of this graph, after these median concentrations have tripled, we've now exceeded that 50 milligram per liter threshold, kind of overall in New Jersey. And so why are we talking about chloride specifically? Well, most road salt compounds contain chloride. We have sodium chloride, that's kind of the most common. That's just your typical table salt, referred to as rock salt. When it's out there, it's kind of in those bigger crystals. We can also use different compounds using chloride, like calcium, magnesium, potassium chloride. Some of these are more effective at lower temperatures. So something like sodium chloride, if your pavement temperature is less than 15 degrees Fahrenheit, then it's not going to be effective at all, and you're basically wasting your salt. And so there's other compounds that are more useful at those lower temperatures. And so chloride is the way that we will tend to measure the impacts of road salt with the New Jersey Salt Watch project. But there's a few other ways to measure road salt or the impacts of road salt. So I figured I'd mention them here. We're talking about salt. Why not measure salinity directly, right? So that is a direct measurement of all compounds of salts. But the measurement ranges for those kinds of tools and tests tend to be on the higher range, so they're more appropriate for marine waters or brackish waters. Conductivity and total dissolved solids, those are other parameters that we use to measure the impacts of salt. They kind of have a quicker reading. So when we measure for chloride, we have to go out to the site. We have to take a sample of that water. So every time there's a physical interaction between a person, whether it's a scientist or a volunteer, going out to collect that sample. Conductivity and TDS, they can be measured with a meter that's a continuous meter. It's in the stream almost permanently, and they can collect measurements, those readings, every 5 minutes, and just beam them through the cloud to you. So that is a much easier way to kind of measure the impacts of salt. But in order to really tease out chloride from all of the other compounds or components of conductivity, we need to be able to do regionally specific studies to see how local geology and land use contribute different types of ions to their conductivity, so that we can specifically say, kind of create I guess, a calibration curve to sort of match up our conductivity and our chloride readings. So that is something that's on the horizon, but for now, we're measuring the chloride directly. So where does the road salt go? It certainly doesn't disappear. Most of the time, road salt sort of, it sits on the road. It can hang out there until the snow starts to melt. And when that happens, the salt becomes aqueous in that melting snow or rain that happens after a storm. And that picks up the salt and can run directly into a storm sewer. I have seen so many big piles of salt just sitting right next to the storm drain, to the grate. And where does that go? Goes directly into the nearest water body, usually a stream or a lake nearby. Or you could have the salt sort of bounce and scatter to the edge of the road, sort of filter into the soil. And once it percolates down, it can work its way into groundwater and then to surface water sort of indirectly in that way. But road salt generally is the primary source of rising chloride levels in snow-affected freshwaters. So that's here in New Jersey, in New England, and in these areas in the northern U.S. where we do rely on salt. There have been long-term studies that have shown that connection between when the use of road salt really expanded in the 60s and that corresponding increase in chloride. So here in New Jersey, we saw the first exceedance of total dissolved solids back in 2002. And so what is an exceedance? That is any sort of indication or measurement that indicates that chloride levels are above safe water quality standards. So if it exceeds that standard, we call that an exceedance. We started to see the total dissolved solids in 2002, and then started to see those chloride exceedances in 2016. And of course, since then, the number of exceedances has grown year by year. Road salt and de-icing in general is not the only source of salt to the environment. If you make pasta tonight and you have your salty water, that goes down the sink. And if that goes to a water treatment facility, typically it's not going to be able to treat that chloride. Most traditional facilities are unable to remove chloride from wastewater. So your bath tonight, if you use salts, that goes directly to the wastewater plant. And then that is discharged to surface water. So there's a lot of pathways for salts to kind of move through the environment. They spend some time in soil, they can move through groundwater, but it kind of ends up in water eventually. So what are those effects of excess salt on freshwater life? Well, I think first we should acknowledge that we're using this word freshwater, and there's only one thing that differentiates what freshwater is from brackish or marine water, and that is salt. And so, of course, it's going to have a huge impact on the biological community living in that stream. If you've got a lot of salts, we have a standard in New Jersey of 860 milligrams per liter of chloride, but some species can handle up to 3,000 milligrams per liter or more. Once it reaches those levels, then we start to see acute mortality, meaning critters just start dying and we start to see fish kills on the side of ponds and streams. We also have non-lethal effects, things that it's not going to kill off the biota, but it's going to impact the way that they grow and develop and reproduce. So that can happen, as I mentioned, there's kind of that threshold, about 50 milligrams per liter, but of course that's a giant range as well. But there has been research to show that in areas that have excess calcium chloride specifically, there were rainbow trout hatchlings that were found to be 30% smaller in that calcium chloride affected water rather than actual fresh water. So we're starting to see some of those fish species become even smaller year after year. There's also kind of an interesting thing that can happen with riparian wood frogs when they're exposed to environments that have saltier water. They tend to shift their sex ratios so that they're birthing more males than females. And so some of the mechanisms of this are not perfectly understood of why this is happening, but it's definitely having an impact on our biota. Sort of something I hadn't mentioned here or hadn't written on this slide, but should mention is that also you can see some species outcompete others, some that maybe have a wider tolerance level of salt specifically. They can push out those native species and kind of shift that community into an invasive one that's based in invasive species instead. Now, with lakes, there's something a little bit more specific that happens when we get really salty water in a lake. Of course, saltier water is denser than fresh water, and so it tends to sink to the bottom of the lake. There's seasonal mixing that tends to happen in the spring and in the fall in our region. And whether that's with kind of wind action or just the differences in temperature, we start to see a mixture of these layers of the lake. So we have the nutrients and that sediment at the bottom, kind of mixing with the really highly dissolved oxygenated environment on the top of the lake. But when we have very dense salt water sitting at the bottom, it prevents that mixing from happening. So you just start to, in that lower level, in that hypolimnion, you just keep losing and losing and losing dissolved oxygen. Now, what happens then is under those low DO conditions or anoxic conditions, then you start to see nutrients that are in the sediment at the bottom of the lake start to leach out nutrients. And then those nutrients can feed bacteria, can feed algal blooms. Then those consume even more DO, and the cycle just continues and continues. And so we've seen an increase in harmful algal blooms in our ponds and lakes in New Jersey over the past few years. And I would say that chloride is certainly one component of that. With our drinking water specifically, there's a wide range of impacts to us when salt gets into our drinking water. Some of it is taste concerns. You don't want your water to taste salty. Another part of it is these illicit sources of sodium. So if you have sodium chloride getting into your groundwater and your well water, and you're not really aware of that, and you're on a low sodium diet, then you've got these kind of intakes of sodium, and you may not know kind of where it's coming from. It could be coming from your drinking water. So again, I had mentioned this before, but salt is not removed by a traditional water treatment plant. So you would need to do like a reverse osmosis sort of system, and that just tends to be pretty costly. So it's not in our typical plants. When salt water moves through our drinking water infrastructure or pipes underground, there's some areas of the state where we do still have lead pipes. We have copper pipes. They were put in the long ago, and they are still there because, again, it's very, very pricey to dig out all of your drinking water infrastructure and replace it. So when you have saltier water moving through these pipes, it's more corrosive water, so it can corrode the inside of the pipe. And then you've got lead being introduced into your water. You have copper being introduced into your water. Road salt was a contributing factor to the drinking water crisis in Flint, Michigan. I mean, that got a lot of press a few years ago. They had switched their drinking water source from one river to another that had more chloride, that was saltier. And they didn't decide to use a corrosion inhibitor on the inside of the pipe, and thus they had a serious lead issue. So the salty water is corrosive on the inside of the pipes. It's also corrosive on all of the other infrastructure that we rely on to get around, whether that's the roads themselves or your car or your paint, bridges, and any other infrastructure around. Salt can do a number on them. So that's we kind of talked a little bit about the problems there. Now we'll start talking about what we're doing to study this issue and to learn more. One of the ways that we're doing that is through New Jersey Salt Watch. This is a project that we launched in December of 2020, and this was based off of the protocol from the Isaac Walton League's National Salt Watch project. So they had already implemented the use of these test strips and a mailing system, so they can just mail it out to people. And we adopted that and kind of made our own little spin on it. And that year was right there in the middle of the pandemic. We needed to engage our volunteers. A lot of them had not been out in the field for quite a while in December 2020, and so we still wanted to be able to collect data. So we found this to be a simple process, a simple test for really anyone to be able to do. It's accessible because we're mailing out kits to folks who sign up, and they can choose any freshwater site that is meaningful to them. And it's cost effective. We're using test strips rather than, we initially had attempted this by doing a meter share, handheld meters, and I was driving them throughout the state and teaching calibration and picking them up and shifting them between groups. And that was not a sustainable way to do this project. So this way has really worked for us. And what do we receive in return? Of course, we receive a lot of data. We receive greater coverage of chloride conditions spatially, geographically, also temporally. So just over time, DEP staff, when they go out to monitor, they may not be able to get out there after a snowstorm to kind of capture those critical weather periods. But volunteers can. They're much more nimble, especially if a stream is just running through their backyard. They can head out there and collect a sample. And so also in doing that, folks are monitoring their own water bodies. They're learning about them. They have a sense of ownership over that water body, and increased awareness of the road salt around it that's getting into their water body. And people tend to kind of fall in love with it and really start to notice the salt everywhere, the salt hanging around at the storm grates, and it makes them want to do something about it, which is the best part. So how it works, New Jersey Salt Watch is very easy. Anyone can head to njwatershedwatch.org/road salt. Also, you can visit that website at njwatershedwatch.org/saltwatch. Both of those addresses head to the same place. There's a form there to sign up, and you can request any number of test strips that you can reasonably work through. Usually I say by the end of April, but ultimately we just want the data kind of whenever you can collect it, even if that's after April. We recommend kind of a minimum of 3 to 6 times during a winter season. It just has to be a freshwater stream or lake, no monitoring in the ocean, of course. And we asked our volunteers over the years to pay attention to the weather and see if they can't capture a measurement before and after one storm event to see how those chloride concentrations change before the salt is applied to the road and after. Because of course we're just trying to understand like the connection. We know there's road salt out there. We know our streams are getting saltier. We want to be able to make that strong connection that it is road salt. That's what's causing that. So the storm monitoring has been pretty great. So how it works, once you have those test strips, you can head out to your stream. Any cup will do, just a small cup. If you're a college student, that might be a red Solo cup. Or if you can't really get down next to your stream and you kind of need to reach over a little bit and maybe put a coffee cup on a broomstick. Or if you really can't get to your stream and there's a big concrete wall in the way, you could put a bucket on a string. Really, any method will do with this kind of testing. You just want to make sure you're rinsing that sampling container with your stream water first before collecting your sample. And then once you've got your sample, you stick your chloride test strip into your little cup with about 1 inch of water at the bottom. And this is just a simple titration based test. It's drawing water up through a small tube in the center of the test strip. And as the chloride reacts with the reagent, it turns the strip white in the middle. So you can kind of see this orange center down the middle here, and this white peak forming up at the top. It's at the top of that white peak that we are measuring our actual chloride result. We do that with a calibration table. So this unit on this test strip here, this is the Quantab unit, we call it, and then we match it with our calibration table. So here you might say that has landed on 2.4 Quantab units with the materials provided with the New Jersey Salt Watch kit. You've got the table, you can check it. 2.4 Quantab units is equivalent to 64 milligrams per liter or parts per million of chloride. And so it's a simple test, put the test strip in, wait less than 10 minutes, compare, and then enter that data into our online form. We're using a Survey 123 form connected to an ArcGIS map. And so all of that data is uploaded, including, of course, the chloride measurement. They will drop a pin to indicate their location, so you can kind of move around a little bit over the season. And then that produces a live data map. So this season, we're in the 2024-2025 winter season, obviously, and here's the live data map as of 7 p.m. today. We have 538 measurements so far this season. And so you can kind of see throughout, this is just a distribution of the different kinds of readings we've had, and the numbers indicate the number of measurements in each of those sort of blocks. So you can scan that QR code if you like to view this live dashboard, and you can scroll around and look at specific measurements. And that QR code will come up later as well. So over time, that was a look at our live data map for this current season, but for the assessment we'll talk about today, I was mainly looking at data collected in the 3 years between 2020 and the 22 to 23 winter season. So that program, we started it in 2020. We had about 400 data points collected in that first year. And then that increased to about 1,025 in that third year. So we had a lot of growth over that time. It is a very easy project to learn. And so people got involved, which I'm so grateful for. So overall, during this whole period, this 3-year period, we had 2,205 data points across 425 sites across the state. There was a range of 1 to 31 measurements at each site. There were about 100 sites that only had one measurement, so that was unfortunate. But on average, there were 5.2 measurements taken at each of those sites. So this is a look at the activity spatially over that time period. And so kind of the more yellow colors indicate more dense activity. So there's more monitoring happening there. In that first year, the activity was kind of mainly stuck in central New Jersey. This is a Watershed Institute program, so we had a lot of participation from our own constituents and volunteers. And Clean Ocean Action over there in Monmouth County, they hopped in early as well and started participating, collecting data on freshwaters in Monmouth County, not to worry. And then in 2021, Musconetcong Watershed Association joined, and you can see the outline of the Musconetcong River here that lit up bright, and they collected an absolute ton of data since then. And then the Food Shed Alliance, that was a major partner that joined in 2022. They've been monitoring the pollen skill and collecting lots of data up there. So, yep, overall, I've got that. So we can jump into what the data actually says. So we'll look at the chloride conditions and the effect of snowfall and weather and seasonality in general. So first, we need to look at these standards. So as I've mentioned, 50 is sort of that level, that minimum or maximum level we're looking at, that threshold between a healthy freshwater system and one that might kind of be starting to be elevated. There's an official standard at 230 milligrams per liter. That's the chronic standard. And then there's an acute standard with the New Jersey DEP at 860 milligrams per liter. So the way that they kind of do that is that no sample should ever be above that acute standard, 860. And then 230, they don't want to see a chronic period where the levels are above 230 milligrams per liter. Our test strips can measure around between around 24 to 650 milligrams per liter. And so when we kind of look at this and start to create a scorecard based on these thresholds, we start to see that we're kind of indicating anything above 230 ppms or milligrams per liter. Those units are equivalent, by the way, and I will just continue to use them interchangeably. I apologize. But anything above 230 milligrams per liter we consider to be impaired. And then anything above the upper limit of our test strip, above 650, we'll consider to be extremely high. We just know it's above 650, but we don't know how high it actually goes. But in that area between 50 and 230, we kind of elevated from moderate at 100 to elevated and vulnerable. So looking at our sites across the state, the size of those circles refers to the number of readings collected at each of those sites. So the larger that circle, kind of the more certain we are about the results from that particular site, because we had more readings there. Overall, we did have a good number of sites that came back with low salt readings, low chloride readings. So primarily it was below that high or impaired level, below 230 ppms. There were 83 sites, or 20% of our sites, where there was not one data point where any measurements exceeded 50 ppms. So it just was consistently remained low. And then we had 63 sites that had that mean chloride reading above the 230 ppm standard. So we start to see some kind of geographic anomalies appear on this map. Of course, we see on the Musconetcong River, you can follow that on my mouse up there in the northwest part of the state. We start to see like those darker pink colors around Lake Hopatcong fade into those lighter colors that go through elevated and then into moderate levels as that river moves downstream. In the central part of the state, we see a lot of those small blue dots. And what that's telling me is that volunteers who are capturing data that's below 50 parts per million of chloride, they are tending to say, oh, great, we don't have a problem. And then they won't go back to use up their test strips. But still, that's good data to have. We want to have that data. And so I'm hoping to break that cycle and just encourage all data to be entered. We looked at, during that 3-year period, at weather conditions within the 48 hours before the measurement was taken, and divided it into these 4 categories, whether that's snow or snow melt, rain, or dry or baseline conditions. So the thought was, of course, this is going to sound rather obvious, but if there was snow within 48 hours of the measurement, it's likely that recent road salt application had occurred, and that there's an initial runoff and scatter of that salt into soils and into our water resources. After that snow starts to melt, or when rain happens, the salt becomes aqueous and it starts to move around, really mobilizes, and we'll get into freshwaters. Of course, when you kind of get too much, a lot of rain, then you start to see a dilution in those chloride concentrations because you have more water. So the relative impact to chloride concentration is basically from high to low as it's presented here. Our mean chloride levels definitely range depending on the weather conditions. So under dry weather conditions, mean chloride was 100 ppm. That is the upper limit of that moderate category we were looking at before. But if there was any snow melt, or rain within 48 hours of the measurement, we got into that elevated category. So we can definitely see that the highest chloride levels were happening when snow had just happened. And we can also look at this on kind of a more macro scale, looking at each year distinctly and the different snowfall conditions we had each year. So that pink bar in the back, that shows the mean snowfall for central New Jersey, and that's on this right x-axis in inches. So that first year in 2020, our pandemic year, we had 35 inches of snow in total. Then that dropped to 16 inches in 2021. And then we just had 2 inches of snow in the 22-23 winter season. So we had a lot of variability there in the conditions. So did our chloride change as a result? Well, we can certainly see that it did. This is showing us a box and whisker plot. In this blue area in the center, this is where 75% of the measurements are happening. And so the X marks where that mean average occurs. So we do start to see that in 2020, when we had more snowfall, we generally had a wider upward range of those chloride measurements, and our mean average chloride was 168 parts per million, which was in that elevated vulnerable category. Same when we had 16 inches of snowfall, but that range sort of got a little bit shorter, so we didn't get those really high spikes happening. And then in that third year, our mean dropped to 83 parts per million chloride. It's about half of what it was in that first year, and we're definitely seeing that range of 75% of our measurements is below 100 parts per million chloride. So again, we're seeing chloride distribution varies with our snowfall totals for sure. Now this is a look at that weather data by month. So taking all 3 years and just averaging them out by month. The pink area in the back again is our average monthly snowfall. And then the blue bar shows median chloride per month. Now, the red line shows the number of exceedances, so the number of times that those measurements exceed 230 parts per million. And we can see the exceedances really follow average monthly snowfall. So when we have that snowfall, we see those spikes in chloride happening in real time. But the median chloride, those blue bars, they're not just elevated during those snowy times, they're elevated for a few months afterward. And so what that's suggesting is that the road salt, it's kind of hanging out in the soil, it's kind of filtering down, and that over a period of a few months, that's when it starts to filter down and starts to hit water. And so some of that salt is going to instantly hit our water resources. Other road salt may take a longer time to get there, but eventually it will. We can also look at the chloride conditions across space and different land uses in New Jersey. So in New Jersey, when we're assessing water quality, surface waters, we tend to do it in this HUC 14 subwatershed unit. And HUC 14, that just refers to the number of digits that specify this subwatershed unit. So a median size of these HUC 14 subwatersheds is about 5,000 acres. And it just follows the natural contours of the watershed and just breaks it up into those smaller and smaller categories. It's an easier way for us to score water quality. So there's 958 HUC 14 subwatersheds in New Jersey. And during that 3-year period for New Jersey Salt Watch, we were active in 200 of them. So in those 200 HUC 14 subwatersheds, we did not have sufficient data to make an assessment in all of them. We were active there, but those areas that have that hatching, that kind of hatch mark, that indicates HUC 14 subwatersheds that have fewer than 8 measurements. So with less than 8 measurements, we're not really sure if there was just sort of an anomaly happening. We're less confident in our results. But in this map, the more opaque, kind of the brighter those colors show, the more readings we have and the more confident we are in those results. Ultimately, there were 96 subwatersheds that had more than 8 measurements, so we kind of felt confident to score them. So there's a little pattern happening up here in the Musconetcong. Again, our friends at Musconetcong Watershed Association did quite a bit of monitoring, so we had a good amount of data. So when we have that much data, we're able to look a little bit closer to understand some trends that were happening. And I'd mentioned this before, but this is just a closer look at what's happening in the Musconetcong River. In the area surrounding, excuse me, Lake Hopatcong, we have mean chloride levels that exceed 150 milligrams per liter or parts per million. And as that river moves downstream towards the Delaware River, and it's moving southwest, those levels start to drop. So we're kind of seeing maybe a little bit of a dilution, or we're seeing a difference in the way in land use and how road salt is being applied in those distinct areas of the watershed. So with this chart, we're looking at all of the Huck 14 subwatersheds and kind of averaging them out, how the percent of land use that would occur in each Huck watershed, that Huck 14 subwatershed, that fell into each of these chloride condition categories. So averaging all of those subwatersheds in that low category and moderate categories. And we're seeing that on average, we have more forested land in those subwatersheds that had lower or moderate chloride conditions. And we had more developed land in those subwatersheds where we had elevated and impaired conditions. And so here's a closer look at that. For each of our Huck 14 subwatersheds, and they're represented twice on this chart. So once as a green dot with the percent forest land within the subwatershed, and once as a red dot that shows the percent developed land within that subwatershed. This blue line down the center, this indicates that 230 ppm standard. So any results falling to the right of that mean that they're exceeding that standard and they're too high. So what are we finding here? We have in the subwatersheds where it's not exceeding 230 ppm, there's lots of variability in the different types of land uses. It's kind of scattered about. But when we exceed that standard, I kind of noticed kind of a threshold happening at that 40 to 50% land use mark. And so this is this green or gray line around 50% land use there. And so above that, we found that chloride was higher in those subwatersheds with more developed land. These are these red dots up at the top indicating more developed land. And then on the bottom of this chart, chloride was higher in subwatersheds with less forested land. So these green dots hanging out the bottom. There are some outliers, perhaps. And so that just means there were areas where we had a lot of forested land and still exceeded our chloride conditions, or vice versa. And so some of that variation could be explained by our behavior, the things that we're doing on the land, how we're managing snow and ice control. And so more impervious land equals more chloride. It's following weather conditions. It's happening after it snows. We're seeing these exceedances that tracking with weather, tracking with when we're applying salt, and it's tracking with impervious surface, which means it's kind of would be increasing road salt on those more impervious areas. You need more salt if you have more roads. And so what are we finding? We are the culprit. Yes, indeed. So not to worry, though. There are some solutions, and we'll talk about that now. First, we'll talk about some road salt solutions that municipalities can take. That municipalities are a big contributor of using road salt, applying road salt. And so with New Jersey Salt Watch, you can scan that QR code again. That will bring you to the story map, kind of the full assessment of all of this data. And so with this municipal assessment, when we get enough data, folks from each municipality will be able to click on their municipality, see their Salt Watch chloride assessment. So I, in this example, clicked on Pennington Borough, which is the home borough of the Watershed Institute. There we had 22 measurements, so kind of felt confident making an assessment there. The readings ranged from 81 to 486, on average 171 parts per million chloride. It's pretty high. But in Hillsborough Township, this was an area where we only had 2 measurements. Of course, that's not enough to really make an assessment, so we're calling that insufficient information. And so if you're from a municipality in New Jersey, you can absolutely participate in New Jersey Salt Watch. Use this as a resource to kind of learn how your own departments of public works are impacting your own water resources. So Sustainable Jersey is one tool that is available to municipalities. This is this is a voluntary program for municipalities to implement actions towards certification for water quality and climate and energy and resource use and all of these things. And you can kind of reach water gold and become competitive with your neighboring municipalities. There's other reasons to participate, and that is grant funding to actually implement these things. Becoming a Sustainable Jersey certified opens up some different funding opportunities. In 2023, there was a new action that was launched with Sustainable Jersey, and that's all about road salt. And so one of the things you can do to earn points as part of this action for a municipality is participating in New Jersey Salt Watch, collecting that data and sharing those results with the community. Of course, there's other big parts of this is actually implementing solutions, training your workforce, and learning about how much salt you're actually applying in the first place. These are all important steps to becoming a smart salter. So here's a look at just some of these BMPs, best management practices that municipalities can deploy. I've kind of broken them up into these different categories. Capital would be like these bigger purchases, something like a live edge plow. For example, that is just a plow rather than just one flat bottom of your plow that just scrapes and kind of doesn't get into the nooks and crannies of the road. A live edge plow has different parts of the plow that can kind of separate and really kind of scrub the road. So you're plowing more effectively. Of course, that's an initial expense. Other things like brine mixing equipment and spreaders or GPS tracking of trucks to be more efficient. It all costs money, but I promise it does pay off eventually. There's behavioral practices, like learning how to calibrate and assessing how the last storm went, learning from it and changing your behavior going forward, training your employees to maybe respond a little bit differently. A lot of these things they just ultimately, it's the triple bottom line. They're saving money, they're saving the environment, and a lot of times we're kind of helping ourselves and making sure that we're using a lot less salt. So you can save up to 30 to 50% of your annual costs while maintaining the exact same level of public safety. So this is not saying don't use salt. This is just saying to use salt in a sustainable, effective way. You can maintain that public safety and reduce those costs. If anyone here is from a municipality, you can learn lots more about this. We just had a webinar as part of Winter Salt Week. That was the last week of January. So you can hit that QR code there to view that webinar directly, or visit our website, njwatershedwatch.org/saltwatch, to view all of the webinars from Salt Week. There was lots of information discussed. And so state government, it's another pathway that we have to explore when we're looking at road salt solutions. And so looking again at this map on the left, this is the New Jersey Salt Watch assessment map that we had just looked at, comparing it to DEP's report from 2022 for chloride. So you can see the map on the left, we have a lot of that pink. That pink indicates impairments, areas where the mean is above 230 ppm. On the right, this map is only showing 8 subwatersheds that are impaired for chloride. So looking at these together for 96 HUC 14s, where we had sufficient data to do this comparison, 44% of those 96 subwatersheds were found to be impaired with saltwatch data, but just 1% of those same 96 subwatersheds was found to be impaired by the last integrated report in 2022. So it seems that there is a little bit of an information gap happening here, and we're not capturing some of these impairments at the regulatory level. Now, why does that matter? The Clean Water Act, it requires every state to do a report, to produce a report of water quality every 2 years. And the idea is that if you have an impaired water body, one that is found to be polluted or contaminated in some way, you have to fix it. Whether that's limiting pollutant inputs, limiting permitted discharges, and putting a priority on funding for restoration projects in those areas. Conversely, if you find an area that's very high quality, non-impaired, really great, you want to keep it that way, then you can implement anti-degradation protection, things like Category 1 protection, where you limit any development next to the stream within about 300 feet. That's a wider buffer than is afforded to other streams that are not as high quality. And so how we assess these water bodies matter because ultimately it will affect how we can fix them. So the next steps for DEP is using the New Jersey Salt Watch data to find those areas, prioritize new locations for monitoring so that we can collect that high-level data, not using test strips, but using meters and lab data to support the fact that we do have more chloride impairments in New Jersey. Once that happens, we'll develop a statewide road salt TMDL, or total maximum daily load, in New Jersey to sort of limit the inputs of salt into our freshwaters. Then we get to training, implementing those best management practices, funding those best management practices at the municipal level. And then hopefully, eventually, we see a measurable change. We start to see a reduction in chloride in our freshwater systems. So this is sort of a look at a very short look at the pathway, this regulatory pathway from collecting data to submitting that data, to analyzing the data, sort of scoring it into that impaired or non-impaired category. You move through all of these steps. You develop your TMDL, you implement it, you fund it. It could take decades for this process to happen. And so we can't just rely on these regulatory solutions. We also have to rely on you. Oh, no. No. It's pretty easy. So what you can do at home is kind of a 3-step process. First, you want to shovel. Just like the mechanical removal of snow is sometimes all you need. Especially today, it was so light and fluffy. I'm just kidding. My neck hurts. So it was heavy. No, but it's good exercise, and you can usually make a pretty good dent. Second, use less salt. And third, after the storm is over, sweep up the salt. You can use it again if it's still in that crystalline form. So this silly GIF is showing how not to apply salt. They're dropping it and they're stepping on where they've dropped it. They're kind of using it again as traction. But no. You want to scatter that salt so that each of those crystals is about 3 inches apart. You want to make sure you leave that space because the salt will not be effective if it remains crunchy like that. It has to go into solution. It has to become aqueous. And again, as I mentioned, sweeping it up after the storm is another key thing. So this just is to visualize. On the left is one little 12-ounce cup. That is sufficient salt to de-ice 10 sidewalk squares. So you can kind of visualize the quantity you might need there. Other things you can do is advocating with property managers, whether it's in your apartment complex or at work, with your municipality directly, to start to look into these best management practices. And if you need to, hype up the cost savings, because it really is a cost savings. Use less resources. It's just a win-win-win. Another thing you can do is spread the word about this with your colleagues, your friends, your family. This is one of those ultimate outreach and awareness campaigns. Everything that we're doing during the winter season, it's going to impact our water resources. So just knowing the impact of what we do matters a lot. And so one of the ways you can do that is participating in New Jersey Salt Watch. You can measure chloride levels near you. So the link is here, njwatershedwatch.org/saltwatch if you're in New Jersey. If you're outside of New Jersey, you can still participate just through the Isaac Walton League's national project. They can send those kits nationwide, and the link is there. So here is my contact info, and again, 2 QR codes if you wanted to take a closer look at the live data map on the left, and then the full assessment of those 3 years of data on the right. So I will stop my sharing, and we can take a look at some questions if there's any.
Hi, everyone. Thanks for joining us. I'm Cindy Kunis with DRGP. So we do have, yes, a few questions. This one came in the beginning of your presentation. So the question is, why data only up to 2019?
Why data only at 20? So I think that was the chart that was showing how chloride had tripled since 1997. That chart only goes up to 2019. That chart was from the DEP's Integrated Water Quality Report. And so of course, the data beyond 2019 would continue to show that elevation in mean levels.
Next one, what does the AS in the assault mean for your title?
Oh, that's funny. It's a pun. It's a bad pun. It's not a clever reference to like arsenic or anything. No. Assault. Let's stop assaulting our streams.
We're all for bad puns. Where does the rock salt used in the roads come from?
Oh, that's a very interesting question. So there's lots of like evaporative processes where you would source salt from the ocean. Growing up in Southern California, I remember just a giant pile of salt. They would literally just kind of heap it onto this pile and then ship it out. So that's my experience with how it's produced, but I'm sure there's other ways too.
In terms of the Delaware River, is there a similar program in PA similar to your Salt Watch?
Yeah, that was what I had just called out, the Isaac Walton League. They have the national project, but even more local to Pennsylvania, the Stroud Water Research Center, they have their own Salt Watch project where it's kind of like our project. They're a little bit more intensive, a little bit more hands-on. And so I would highly suggest reaching out to Stroud to learn more about that.
Wonderful. Is there an environmentally friendly treatment other than salt that can be used for road treatment?
Yeah, so gosh, that's why we say smart salting, because ultimately there's not a lot of alternative products that we can use. Regionally across the US, there's different areas of the country where in Wisconsin, you may have an excess of cheese brine, or in other areas, they might use beet juice to kind of add to your brine to make it more effective. In the Northwest US, they use like volcanic ash. In Japan, they have installed heated pipes under the sidewalks and roads, so they just melt it off. Now, that would be quite an investment for us to do that. So rather than that, the 2 things that I'm really pushing of all the BMPs is switching to brining over using the rock salt. Brine usually uses a solution of about 20 to 30% salt. And so it's much less salt to start with. It stays where you put it. It doesn't scatter and bounce around. And then equipment calibration is another thing. A lot of trucks, they come quote, pre-calibrated, and they say that you're putting so much salt on the road per lane mile. But when you actually go to look at how much salt you're putting on, it's like double or triple that amount. So literally just checking those controls and making sure everything is doing as you think, performing as you believe it is.
Even those little sidewalk salters. So in my neighborhood, they salt my sidewalks a lot.
Yeah.
And I don't wear my shoes in the house, but I do end up with salt in the house from carrying my shoes up the stairs and
Oh,
it
yes.
coming off. And I was just like, come on, we don't need so much. Because, like you said, there's that crunchiness.
Yeah.
Now, when I had a farm, I used to use sand, and
Hmm.
that's what I would continue to use, just as a grip. If it
Yep.
melts or not, at least I have a grip.
That's what we do at the Watershed Institute. We've got a great property management crew, and they will plow to the best of their ability, try to scrape it up as much as they can. And then if it is icy on top of that, sometimes, the snow you'll plow it or shovel it, and then it will maybe melt a little bit during the day and then ice back over at night. That's when it gets that's like really dangerous. And so that's when you do want to rely on those, abrasives like sand, or people have used like kitty litter or something in the past. But just with how much salt is being applied, a lot of times the focus is on liability.
Mhm.
So people don't want to get sued if someone falls on their property due to icy conditions, and so they tend to over apply. One of those webinars that I referred to from Winter Salt Week, you can find it linked on our website. Goes into some policy solutions. So one of those things is like if you participate in the certification program to be a snow and ice professional, a smart salter professional, then you are exempt from being sued. If you can provide evidence that you're applying the salt as you should and not overly applying it. So there's lots of different strategies out there to try to minimize it. But I find maybe the most effective is just, again, saying how cheap it is to not use that much salt. That's just a
That's
big benefit.
that's what I was thinking, because I thought, wow, the salt would go so much further if they just didn't put so much there. And the irony of it is they salted for a snowstorm. Then we got that ice storm. And I'm not sure if they salted before and it ran off or not, but we had icy sidewalks.
Oh yeah. Oh yeah. Because it's the brining before the storm is really the key. Like if you can prevent that ice from sticking to the pavement, then you're kind of well on your way to manage your conditions a little bit better.
Absolutely. So we have a comment. I see white salted rocks along the Muscanac Calm. Now, is there a chance that that is salt, or do you think that's algae?
Hmm. Yeah,
That
I don't know,
algae
and I
part.
don't want to guess. I'm not sure. I could look at a picture if you have one, see kind of what that looks like.
The algae
But
part
I'm
is the
not
part
sure.
I threw in because I kind of suspect it's possible it could be that on the rock instead of salt.
Oh yeah. Oh sure. There's lots of things that can kind of coat the rocks along the edge, like limestone. That just yeah. There's lots of different things. I see someone just posted that we ran out of salt a few years ago. A lot of times, at a state level, they are very responsive to people complaining. So in 2018, there were a lot of people tweeting after this storm saying, "Oh, it took me 6 hours to get home." And then the whole rest of that season, every time there was like a hint, a whisper of cold air, they would salt the crap out of the roads. Um, and so it really depends kind of on a local and regional level how they respond to concerns and how they can kind of react to weather.
Yeah, I remember when I was a kid, I don't think they salted and plowed as much as they do now. That I think a lot has changed.
Yeah, people really want to get around, and if they can't, people want to just live like it's a normal day. And I understand that, and especially for like emergencies, that's critical. But I think we have to lower our expectations a little bit for just for this. I don't know. We can still drive around. We can wait a week to go to Target. I don't know.
I don't know. Sometimes you need that cereal or milk or bread and
I
eggs or whatever it
know.
is. um, okay, so if anybody's interested in volunteering, you can email me and I'll forward it to Erin. I'm Cindy at delawaregp.org. I saw there's a comment about being interested in getting test strips. I think you covered this. Brining the road before a storm is better for the environment than salting during the storm.
Yeah, absolutely.
Also, comment we use broadcaster only if it's necessary for us due to ice. And then someone said they ran out of salt, but they still made it through.
Yeah, yeah. It's just shoveling. Sometimes that's all you need.
Yeah, absolutely. Here's another question. Is it true that all that salt is harmful to pets' paws and also wildlife? Which is really why I used sand at my barn, because I didn't want the salt affecting the horse's hooves.
Course. Yeah, no, dogs especially. I mean, you can get little booties for your dogs to walk them around the neighborhood, but if you're in a place where they oversalt those sidewalks, and especially if they're using different compounds like acetates and things like that, it's going to irritate their paws. And so, if your dog refuses to put on shoes, then that's also worth looking into lowering how much salt we're using and communicating that with your property managers as well.
Well, you know, dogs love those booties. As you see those videos of them trying to shake them off.
And, and they forget how to walk
Oh, that's true.
a
Yeah, yeah,
little
the
bit.
high
Yeah.
stepping. So here's another one. Apologies if this was covered. Are smaller creeks and tributaries in urban areas more susceptible to high salt levels versus larger rivers?
I would say yes, and that just has to do with the volume of water there. And especially if you're in an urban area, you're going to have that direct input of road salts in your surrounding watershed. And so when that goes into a smaller stream, you have less water, that concentration is automatically higher. Also, what happens in those smaller urban streams is that in the summertime, when it starts to get a little bit droughty, they have even less water, and so it concentrates the salt even more, and you start to see those chloride spikes in the middle of summer. Huge chloride spikes, especially when groundwater that has been contaminated has to kind of feed surface waters during those droughty times.
Yeah, you don't even think about that delay of hitting it.
Yeah, that the median kind of it from our data from after the last snow in like February, March, that median stays elevated to April, May. So that's a good couple of months. And then the groundwater, when it starts to feed the surface water in July, August, then we see another spike. So there's really not like a high chloride season anymore. It's just this persistent condition.
Wow. And I liked your reminder, or I actually learned something new about this, the salt in your pasta water. That was a good one, because I think most people do salt their pasta water
Oh
and they don't
yeah.
even realize.
And I am not saying to not put salt in. Let me be clear. Let's not become a victim of scale. That how much salt is being applied on the roads is way more than your pasta water. I just said that to kind of
Makes you think.
bring awareness to the fact that everything you're putting down that drain, it's not like it's just disappearing at the water treatment plant. A lot of that is just being passed along to the discharges to surface waters. Salt is a big part of that.
It's very true. And with all the salt they put in my neighborhood, one day I thought, oh, I can't wait for it to rain to get rid of this stuff. And then I was like, oh, I don't
Yeah,
know where it
yeah,
goes,
because it
unfortunately.
like get rid of, right? Yeah,
Yeah.
that concept.
Wait a minute. Okay, so here's another one. Here in Princeton, I could collect from Lake Carnegie saying that wrong, Lake Carnegie, or any number of small streams. Are either of these more valuable in terms of data collection? Does distance from road matter?
Ooh. Ooh, that last question, that's interesting. So I'm not sure about how valuable they are comparatively. I think might invite you to look at the live data map of the 2024-2025 season and see what kind of activity we had going on. And if Carnegie Lake's not covered, I'd love to have a site there. Distance from road. That is a question I was trying to answer when looking at land uses here, and we needed a little bit more firepower to be able to delineate the watersheds for each of those sites. But that's something I'm absolutely interested in looking into to see how far it travels.
Wonderful. So I'm not getting any more questions. Just put in chat where we will post a recording and also other former lectures. If you missed one or you see a topic that piques your interest, we have a YouTube channel and links in chat. So I just want to say thank you, Erin, so much for teaching us about this and what we can do about it, even if it's just going to your HOA or property manager and
Yeah.
saying, hey, can you reduce that so my sidewalk's not completely white and crunchy? It's the small things that also help as well. And I got to thank you in Q&A. So it looks like we have audience appreciate it. Thank you so much and have a wonderful night.
Thank you so much. I really appreciate it. Thanks to all the attendees today.
Thank you everyone for joining us.
Have a good night.
Good night.